In this video, I'm going to solve some 9 questions from the chapter Exponents and Power, class 8. Let's say begin with the first question here. In the first question, we have to express this as a power of, that is, we have to express 9 raised to the power minus 3 as a power of base 3. So what we know that 9 can be written as 3 raised to the power 2. So if I replace this 9 here, right? If I replace 9 as 3 raised to the power 2, make sure I just replaced 9 here, not this whole thing, right? So this minus 3 power will be as it is. Once again, this 9 here is replaced by this, right? So we got 9 as 3 raised to the power 2. On simplification, what we can see, this is power over another power is power multiplied. So that is 2 into minus 3 is minus 6. So we'll write this is equal to 3 raised to the power minus 6 as the answer. In the second question, which is from the chapter rational number, it says, by what number should this be divided to get minus 5 by 2? So let's say the number with which this is divided, let's say I took this number as x. So what we can say that, we can say here that is minus 8 over 25. Say if it is divided by, I took the number with which is divided as x to get minus 5 by 2. Now, what you know that this x is divided here, then if you transpose it to the other side, it should be multiplied. So we can say this is minus 8 over 25. If I transpose this divided by x to the other side, it gets multiplied. So this is multiplied by x. Now, as we can see that we have to get the value of x here. So we'll be transposing this to the left. And you must be knowing here that if I do so, let's say if I do here, this is minus 8 over 25. If I transpose this to the left-hand side, what happens? It gets multiplied by its reciprocal, which is 2 over minus 5, or you may write minus in the numerator as well. Now, we can see that's minus and minus gets cancelled here. And on the right-hand side, we are left with x. So for further calculation, this is 8 into 2, that is 16, and 25 into 5, that is 125. So that should be the value of x. We can write a statement that minus 8 by 25 should be divided by this to get minus 5 by 2. In the third question, it says we have to find the value of m for which 9 raised to the power m divided by 3 raised to the power minus 2 is equal to 9 raised to the power 4. So what you can see that the lowest prime number is 3 here, and we can write 9 and 9 here in terms of 3. So once again, we can see that 9 can be written as 3 raised to the power 2, that is 3 square. So if I replace this 9, if I replace the first 9 as 3 square, I replace simply this 9. As you can see here, that's this 9 here is replaced with 3 square, but rest will be as it is. So the rest thing, that is, there is a power of m over here, and that divided by 3 raised to the power minus 2. Similarly, here also I can replace 9 with 3 square, that raised to the power 4. Now we know that power over another power is power multiplied. So we'll write 2 into m, that is 3 raised to the power 2 into m is 2m, right? 2 multiplied by m is 2m. That divided by, let it be 3 raised to the power minus 2 only. And this can be written as 3 raised to the power 4 into 2, that is 8. Now check here, we have the same basis, like over here, we have the same basis, right? And they are divided. So we know that when same bases are divided, the powers are subtracted. So it will be 3 raised to the power 2m. We'll give one subtraction sign, right? We have to subtract these two power, right? This power and this power. So we'll write this minus this, right? So this is the reason why we have 2 minus. 1 minus is for this power, that is minus 2 here. And the second minus is for the property, that is the property which I'm applying here. is a raised to the power m divided by a raised to the power n is a raised to the power m minus n. That is the laws of exponent. Now, continuing with this step, I can carry forward this 3 raised to the power 8 as it is. Now, you can check here that this is 2m minus into minus is plus. So this is plus 2 is equal to 3 raised to the power 8. Now we are going to use another property here that of laws of exponents. Say this is a raised to the power m. If it is equal to a raised to the power n, then we can equate their power. That is m is equal to n. This is what we are going to do here. You can see that we have same basis here. We have same basis, so we can equate their power. That means we can write this power is equal to this. So we'll be writing this as, say, 2m plus 2 is equal to 8. So that implies on transposing 2 to the other side, it is 8 minus 2, that is 6. And finally, we can say that dividing 6 by 2 will get m is equal to 3. So finally, we'll say that the value of m here, the value of m so calculated is 3 years. In question number 4, we have to simplify this and write the exponential form with a negative exponent, right? It's very important to remember that we need the answer in negative exponent. Now, the property we'll be applying here is that, let's say, a raised to the power m raised to the power n is a raised to the power mn, right? That means, like, say, if you have a raised to the power 3 whole raised to the power, say, 7, should be a raised to the power 3 into 7, that is 21. So if I apply this property here in this question, we can say that this is 3 by 7 raised to the power minus 2 multiplied by minus 3. So this is minus 2 into minus 3 is positive 6, right? Minus 2 multiplied by minus 3 is positive 6. But as you can see that we need the answer in negative exponent, and you must be knowing that this is same as if to make the power or the exponent as negative, we have to reciprocate the base. So I reciprocated the base, which was 3 by 7, now is 7 by 3, which is equal to. Now make sure you do not get confused with this. This is not the reciprocal of this. They are same, right? They are equal, and we just write in a different way. So we got this answer. The final answer should be in the negative exponent, and that's why I wrote 3 by 7 raised to the power 6 as 3 by 7 raised to the power minus 6. In question number 5, we have to simplify this exponent. Now, the best way to solve this thing is that whatever has a negative power, like this is z raised to the power minus 3, if you bring it to the denominator, it becomes positive, and vice versa. That means if z raised to the power minus 5, if you bring it to the numerator, it becomes positive. So will happen with the 7 raised to the power minus 3. If I transpose it in the numerator, it will have a positive power. So that is the first thing which I'm doing. I'm writing. Moreover, you can see that 49 can be written as 7 square, as we are required to use laws of exponent. So what I did, I wrote 7 square. Then this has a negative power in the denominator. So I'll write with a positive power in the numerator, as I told you. And this z raised to the power minus 5 has a negative power in the denominator. So I can write z raised to the power positive power in the numerator. Now 10, which is already positive. So we may write 2 into 5, but there's no use because there is no 2 and 5. So we can keep it 10 only. And similarly, z raised to the power minus 3 can be written as z raised to the power positive 3 in the denominator. So once again, what I'm doing here, as I told you that one with a negative power, if in the numerator, we can make it positive by writing in the denominator. So I wrote z raised to the power minus 3 as z raised to the power positive 3 in the denominator. Similarly, it was 7 raised to the power minus 3 in the denominator is transposed. And if it is written in the numerator, become positive. Likewise, z raised to the power minus 5, which was negative in the denominator, when written in the numerator, becomes positive. Now, over here, I'm going to apply the laws of exponents here for these two, and we'll also apply laws of exponents on the other two. So the places where we are going to apply laws of exponent. Now, first I'll tell you what is the laws of exponent we are going to apply. Number one, that is a raised to the power m into a raised to the power n is equal to a raised to the power m minus n. The other which I'll apply is a raised to the power m divided by a raised to the power n is a raised to the power, this is plus, sorry, this is plus in case of product, the powers are added, and this is m minus n. So the laws which is being applicable here, so the two places where I'm applying laws of exponent is this and the other over this. So what you can see here that this is same bases are multiplied. So applying this property, we'll say that powers will be added. So it should be 7 raised to the power 5. And if I apply laws of exponent over here, I should say that this is z raised to the power 5 minus 3 by applying this property. That is same basis divided, powers are subtracted. That divided by 10. So we do not need to further simplify this. We'll simply write this as 7 raised to the power 5 only. And this is z raised to the power 5 minus 3 is 2. That divided by 10. So that should be the final answer for this in the simplified form. We are now in question number 6. It says that if 3 raised to the power n is equal to 729, then what is n is equal to? So for that, we are supposed to write 729 as a power of 3. So, and that is possible by prime factorization. So if I prime factorize 729, it's divisible by 3. 3 2 times is 6. Right, remainder 1, that is 12. 3 4 times and 3 3 times. Further with 3, 7 times is, sorry, 8 times is 21 and 1 times is 3. Further with 3, 27 times, 3 9 times, 3 3 times, and 3 1 times. So you can check here. I can write this as 3 raised to the power 1, 2, 3, 4, 5, 6. So this is 3 raised to the power n, and I can write 729 as 3 raised to the power 6 here, right? So this is 3 raised to the power 6. Now we know there's a property that if it is a raised to the power m is equal to a raised to the power n, then we can equate their power, that is m is equal to n. So using this, I can say that I can write these two power as equal. So we'll say that n is equal to 6. So the answer for this will be n is equal to 6. In question number 7, we have to write this in the standard form, that is scientific notation. So we can see here that this is going to be a very small number, and small numbers are indicated by negative power. Students have confusion that when they convert them in power, should they write a positive or negative power? As you can see, this is a very small number, must be having a negative power. So the decimal will come over here, that is between 1 and 8. So it's 1.82 that into multiplied by 10 raised to the power. Now check here, how many places are we shifting the decimal? 1, 2, 3, 4, right? So shifting it to the decimal as 4 places, right? As I told you, it's going to be a very small number. Small numbers must have a negative power. So the final answer for this is, when written in the standard form, as for the question, also known as scientific notation, is 1.82 that multiplied by raised to the power 10 raised to the power minus 4. Now we are on the final question, that is question number 8. It says that we have the mass of Mars, planet Mars, is 6.42 into 10 raised to the power 29 kg, and that of Sun is 1.99 into 10 raised to the power 30 kg. What is their total mass? That means we have to add them. But then we can see that they do not have the same exponential power. So that means we need to first convert them into the same power. But anyway, what we have to do is, if I have to add, let's say, if I have to add these two masses, this is 1.99 into 10 raised to the power 30. Now, as I said, that we cannot add these two numbers unless they have the same power, right? So we need to convert them into the same power. So what I'm going to do is I'm converting 10 raised to the power 29 as 10 raised to the power 30. So this is possible if I multiply divide by 10, because you can see here that we need a power of 29, right? So what we can do is if you multiply by 10 and divide this number by 10. So I can write multiplied by 10 and divide by 10. Now you'll soon realize why I'm doing so. Now you can see that this 6.42 divided by 10 will give you 0.642. We did so as to make as 10 raised to the power 30. As you can see here, 10 raised to the power 29 multiplied by 10, that is 10 raised to the power 30. Plus this is 1.99. I can write an extra 0 so as to make an equivalent decimal place, multiplied by 10 raised to the power 30. Check here, we can take 10 raised to the power 30 as common here. That is, I can add 0.642 plus 1.990. Why? Because I have taken 10 raised to the power 30 as common. So once again, we have taken 10 raised to the power 30 as common, as you can see here. So we'll be adding the remaining numbers. That means the numbers added are this and this. So I wrote it over here. So further calculation, this is, if I add, this is 1. If I add from behind, that is 2 plus 0 is 2. 9 plus 4 is 13, carrying 1. And 9 plus 6 is 15 plus 1, 16, carrying 1. 1 and 1 is 2 into 10 raised to the power 30. Now question arises, why did not I converted 30 as power of 29 and I did the reverse? This is because when writing in the exponential form, you must have the decimal after the first digit. And that is the reason why we have done this. So the final answer we can say after the total mass of this, and must write down the unit. That is, we have the unit as kg as 2.632 into 10 raised to the power 30 kg.